So as we start with our first drawing, what I'm going to do is I'm opening up GeoGebra. I have an Algebra tab open, a Graphics tab open, and I'm also going to go ahead and open up a spreadsheet view over here on the right hand side. Now in my graphics section, I'm going to draw in my circle, just any old circle. I'm then going to draw in a tangent line at the point B, but in order to have a line tangent at point B, I first need to have my radius from A to B. So I'm going to draw in a segment from A to B to represent the radius. My tangent line has to be perpendicular to AB at the point B. So I'll use my tool there to draw in a perpendicular line. So this segment we see here is now tangent to the circle A at the point B. And then I'm going to go ahead and draw in a line segment starting on the circle and meeting up with the tangent line somewhere out here to the right hand side. That will be the point D. I'm also going to need to label points of intersection at E. That will separate my secant line up into two parts. Now, I need some measurements. So currently, you'll see I have D, segment D. This tells me that it is from the point C to the point D. I also have in here segment A, which is AB. That's the radius. So I'm not actually going to need that measurement. I do need D. I also need the measurement from E to D. And I also need the measurement from B to D. And so now we can see I have defined segments at BD. That's the exterior tangent segment. I have the segment here at E, which is from E to D, and the segment D, which is from the point C to D. Now, my relationship that I'm going to verify says this, and this is where my spreadsheet's going to come into play. So over here, I'm just going to type in D. That will bring over the length of D, 9.25. I'm also going to type in the segment E. That will bring over the length of segment E, which is 5.2. And then I want to calculate the product. So I'm going to just type in here equals, and I click on cell A2 times A3. And we'll see that that gives me the product of 48.08. I then want to calculate the tangent piece, which is F, and we're going to square that. So over here in B2, I'm going to put in F. Again, 6.93, you'll see that carried over. And then I'm also going to put in here my formula to square that is B2, and we'll just do it the easy way, times B2. That would be B2 squared, 48.08. You'll see that those two values are the same, which verifies our formula. Because GeoGebra is dynamic, I can grasp a hold of the point D and slide the point D along my tangent line. And notice no matter where I end up along the tangent line, my relationship holds true. So again, I'm starting out for this second relationship between two secant lines. I've got my Algebra tab open, my Graphics window open, and a spreadsheet open. In my graphics window, I again will draw in a circle. I do not need to be concerned with a tangent line at this point. I'm simply looking for two secant lines, so I'm just going to draw in two quick segments. One of them C. I'll draw in another segment, have them both meeting at a point outside. So those are my two exterior, my two secant segments. Then I need my exterior segments. The first one going from F to D, and the second one going from G to D. And then again, just like I did in the previous example, I'm just going to go ahead and type in A, D as my segments from C to D and from F to D. And then I'm going to type in B and E, which would represent my segment from E to D and from G to D. And then my formula here, again, I'm just multiplying cell A2 by cell A3 and multiplying cell B2 by cell B3. And again, you see that similar relationship. Once again, since GeoGebra is dynamic, I can grab any of those points, and as I move them around, those will stay the same. Same with the point D. As I move to point D, you'll see that the relationship of the product of the segments, the entire segment times the exterior piece, is equal to the entire segment times its exterior piece.